Hello and welcome to today's lesson where we're going to look at electromagnetic wave properties, which is part of the waves topic in GCSE Combined Science. So in today's lesson we're going to look at understanding the different properties of electromagnetic waves. So if we're successful and we learn in today's lesson, we should be able to define what an electromagnetic wave is, understand what the electromagnetic spectrum is, and describe the uses and hazards of the different sections of the electromagnetic spectrum, which is part of the properties of electromagnetic waves 2 section of the AQA GCSE Combined Science specification in physics. So radio waves are used to transmit information around the Earth to allow for communication. Now they do this via reflection off the ionosphere, which is part of the atmosphere full of charged ions. Now radio waves are transmitted from a transmitter aerial. They will then reflect off the ionosphere and they'll then be received by receiver aerials. Now this process is stronger in the winter months as the temperature is lower. This means the particles in the ionosphere are moving slower on average. So the ionosphere is denser in the winter and it makes it easier for the radio waves to reflect. Now again, this process can allow radio waves to be transmitted across many thousands of kilometers. Now it's important to note that radio waves are broadcast with a radio wave transmitter aerial, which is a metal pole capable of carrying a current, such as this particular transmission station. Now it's important that they're made from metal because they need to contain many free electrons. Now when you want a transmitter to transmit a radio wave, you've got to pass an alternating current through the aerial. This will cause the electrons in the aerial to move backwards and forwards at a particular frequency. So say for example they're moving backwards and forwards at 30 Hertz. So that means 30 times every second. This will cause a radio wave to be produced and emitted from the aerial. So the alternating current causes a radio wave to be emitted. Now the radio wave produced has the same frequency as the frequency of the alternating current. So if the alternating current has a frequency of 30 Hertz, the radio wave has a frequency of 30 Hertz. So they both have to be the same frequency. Now note, this process also works in the other direction as well. So say for example a receiver aerial absorbs a radio wave. Well, when the radio wave is absorbed, this deposits energy into the aerial and causes the electrons in the aerial to oscillate backwards and forwards, producing an alternating current. Now the frequency of the alternating current is the same as the frequency of the radio wave absorbed by the aerial. So if the radio wave was 50 Hertz, the alternating current in the aerial will be 50 Hertz. If it was 20 Hertz in the radio wave, it will be 20 Hertz in the aerial. So they have to have the same frequency. So radio waves can be produced by oscillations in electrical circuits, an alternating current. When radio waves are absorbed by an aerial, they may create an alternating current in the aerial. Now in both cases, the frequency of the alternating current equals the frequency of the radio wave. Now electromagnetic waves can also be generated or absorbed when they interact with atoms. So electrons exist in shells or energy levels around an atom. Now when electrons move down energy levels, they will release an electromagnetic wave. This is because the lower energy levels have less energy than the higher ones. So the electron needs less energy to exist on the lower levels compared to the higher levels. So when it drops down, the electron has excess energy which it gives off as an electromagnetic wave. Now when electrons move up energy levels, they do this by absorbing an electromagnetic wave. This is because the higher energy level has more energy than the lower one, so the electron needs more energy to exist on the higher level, which it gets by absorbing an electromagnetic wave. Now in addition to the movement of electrons producing electromagnetic waves, gamma waves can also be generated in the nucleus of an atom, because an unstable nucleus can become stable by releasing a gamma wave. Now that's an important process which was covered in the topic atomic structure. So let's just clarify, in changes in atoms and the nuclei of atoms, that can result in electromagnetic waves being generated or absorbed. The electron arrangements may change with the absorption of electromagnetic radiation, moving further away from the nucleus to a higher level, or by the emission of an electromagnetic radiation, moving closer to the nucleus, a lower energy level. And gamma rays originate from changes in the nucleus of an atom. Now, radiation which is harmful to humans is called ionizing radiation. This is radiation which has so much energy that when it hits an atom, it knocks electrons out of the atom. This process is called ionization because it turns an atom into an ion and releases an electron. So you can see in this particular diagram, alpha rays are removing electrons from this particular atom. Now, this ionizing radiation can cause our DNA in our cells to be ionized. So when this happens, we say the DNA has mutated, which can lead to cancer in a person. Now, the chance of radiation leading to cancer is measured in sieverts. Now, sieverts measure the risk of harm from the exposure of a body to radiation. A dose of 1 sievert gives a 5% chance of developing cancer. Now, radiation which can do this is called ionizing radiation and can include gamma rays and X-rays. Now, radiation which can cause this, like we said before, is called ionizing radiation. So ionizing radiation can either be nuclear radiation like alpha particles, beta particles, but also electromagnetic waves like UV or X-rays. Now, gamma radiation is an ionizing radiation which is both nuclear radiation and electromagnetic waves. Now, the chance of cancer measured in sieverts is dependent on the type of radiation and the size of the dose. The more ionizing the radiation type, e.g. gamma is more ionizing than UV, the greater the risk of cancer. The larger the dose of radiation, the greater the chance of cancer. So the greater the exposure to ionizing radiation, the greater the risk to the human being. So to clarify, only the high energy regions of the electromagnetic spectrum are damaging to humans. Damaging radiation is called ionizing radiation. And ionization is when the DNA of cells is altered when the waves cause electrons to be knocked off the atoms and change the DNA. The higher the frequency of a wave, the more energy it has, so the greater ionizing ability it has, which the damaging ability of radiation is measured in sieverts. And examples of ionizing radiation include gamma rays, X-rays and UV rays. So to summarize what we've learned in today's lesson, radio waves can be produced by oscillations in electrical circuits. When radio waves are absorbed, they may create an alternating current with the same frequency as the radio wave itself. So radio waves can themselves induce oscillations in an electrical circuits. Changes in atoms and the nuclei of atoms can result in electromagnetic waves being generated or absorbed over a wide frequency range. Gamma rays originate from the change in the nucleus of an atom. Now, ultraviolet waves, X-rays and gamma rays can have hazardous effects on human body tissue, and the effects are dependent on the type of radiation and the size of dose. The radiation dose in sieverts is a measure of the risk of the harm resulting from an exposure of the body to the radiation. Now, 1000 millisieverts is equal to 1 sievert, and you should be able to draw conclusions from given data about the risks and consequences of exposure to radiation. Now, ultraviolet waves can cause skin to age prematurely and increase the risk of skin cancer. Now, X-rays and gamma rays are ionizing radiation that can cause the mutation of genes in cancer. So if we've been successful and we've learned in today's lesson, we can define what an electromagnetic wave is. We understand what the electromagnetic spectrum is, and we can describe the uses and hazards of the different sections of the electromagnetic spectrum. I hope you've enjoyed today's lesson looking at electromagnetic wave properties, which is part of the waves topic in GCSE Combined Science. Thank you very much for listening and have a lovely day.